Welcome to this Lacework Forti CNAPP feature overview, where today we'll touch on some of the key capabilities and common workflows associated to the newly released Code Security Smart Fix capability.
For any team that owns the long-term maintenance of an application, they understand how building robust applications quickly often means using third-party dependencies to save time and make software more maintainable. However, these dependencies can also introduce vulnerabilities into the application, posing significant security risks. Identifying and resolving these vulnerabilities is crucial, but figuring out the best upgrade path isn't always straightforward. Lacework Smart Fix isn't just another vulnerability scanner. While typical tools might inform you of a safe version to patch a specific security hole identified by a CVE, Smart Fix goes several steps further. For example, in this diagram on the left, we have a log4j vulnerability, CVE 2021-44228, in our open source library, which is at version 2.11.2. According to the CVE 2021-44228, to address this log4j vulnerability, the fixed version is 2.15.0. But 2.15.0 has another critical vulnerability, CVE 2021-45046. Taking the recommendation from the CVE would mean potentially several more iterations on upgrade planning. This is where Smart Fix comes in. Smart Fix will enumerate all of the versions starting with 2.11.2, checking to see which versions not only resolve the vulnerability for log4j, but also result in the open source library not being vulnerable to known CVEs. It iterates through 2.16 and 2.17, then finds 2.17.1, which has no known CVEs. The 2.17.1 version will be the Smart Fix recommendation. Providing this best path to upgrade can save code owners a significant amount of time, ensuring that upgrades provide the most effective outcome without the need for further manual assessment. All right, let's take a look at Lacework Smart Fix in action. We're here in the repository of our fictitious company, Interlace Labs, where we have this vulnerable log4j application. Let's review the Smart Fix recommendations provided in this pull request to see how Lacework Smart Fix works. In our repository, we have Smart Fix configured to assess our pull requests, where we scan the project to detect vulnerabilities associated with third-party dependencies. In this case, Smart Fix identifies a number of vulnerabilities, including this critical log4j vulnerability associated with log4j core, version 2.11.2. Let's look at the breakdown below. First, we can see the CVE associated with this vulnerability and the fixed version recommended by this CVE, which in this case is version 2.15.0. So if all we had to work with here was the information related to the CVE, we might assume that upgrading to version 2.15.0 would leave our application in a non-vulnerable state. But this is where the assessment by Lacework Smart Fix comes in. In the summary here, we can see that for each possible upgrade path, Smart Fix checks to see if there are any other vulnerabilities in the upgrade path. Once it's found a non-vulnerable version, it uses that version for the recommendation. We can see that in fact 2.15.0 is vulnerable to a number of other CVEs. If we chose to upgrade to 2.15.0, we'd need to go through this exercise of upgrading again, because we still wouldn't have ended up with a non-vulnerable version of our application. With Smart Fix, Lacework is empowering developers by automating the complexity of dependency upgrades. This feature ensures that teams not only fix vulnerabilities faster, but do so with the confidence that they're choosing the best possible version for their software's longevity and security. Thank you for taking the time to watch this video.